Okay, recording is started. This is the June 25th KEP review for the Object Bucket API. I'd like to first share screen here. And just please let me know that that's like coming through for you and it's readable.
I can see it, John.
And you can see it. Okay, great. Yeah, so a few topics to touch on right now. I've pushed an update to the KEP with the latest bucket APIs as we've been discussing them. So that would look like this. There's also been a bit of restructuring. I've parsed out some of the paragraphs I thought may have been redundant and kind of jumped straight into the APIs, and then pushed architecture and diagrams further down. So you'll see now, I'm not going to go through these, but just know that they're up, they're ready for review and for questions. Some of these APIs are going to be further down the slide, so we'll talk to those in a bit. So bucket request and bucket.
Yeah, and notice he's using the new names for the objects, for the Kubernetes resources.
Yeah, thank you, Jeff. So these, I promise that we're not going to change the names again. I'll say that. So bucket request is our new user namespace, not new object, but new name for the namespace object, formerly bucket. Bucket is the cluster scoped object, formerly bucket content. Further down, we have our bucket class remains unchanged, and then the access APIs that we've also discussed. So the bucket access request, the bucket access, and then the bucket access class. Also added a diagram here, which hopefully details a little bit better the interaction. So I do want to talk to this for a second. So according to the legend down here, so the only creation that I'm indicating at the moment, this is still, I'm trying to tread water, tread between the high level view and a little deeper down kind of relationships and interactions. So blue indicates references. So if the arrow is pointing from an object to an object, the object is contains a reference to that object. So this hopefully clearly depicts the interrelationships by actual field references between the APIs. The black arrows indicate that a workload or pod is accessing an API. So in this case, you see the cozy controller is reading from bucket access request, bucket access class, and also the bucket request in the bucket class. It then creates the bucket access CRD and the RL API instance and the bucket instance. And so that the logic follows through there. Further down is stale. That's kind of pending some of the architectural discussion that we have today. So if you're reviewing this, I wouldn't go beyond this diagram for the moment.
Yeah, also for the moment, I've written the Go equivalents for this specific API spec and generated the clients for them. It is in our old repository that we were coordinating with, the container object storage interface org. I'm going to paste the link to that, but I'll be moving it to our new repositories. I don't know if everyone knows, but our a repository or two repositories for container object storage interface have been approved by Kubernetes SIGs, I believe. I don't know who the approver is, but yeah, we have that, and we can start pushing code into the official repos now.
Right. Yeah. Thanks. So that's awesome too. Since y'all have had a couple of seconds to digest this, are there any questions that immediately come to mind that I can answer for y'all? I'll just give it a minute.
I'm still absorbing, but
yeah, I know there's kind of a lot going on. Okay, great. Yeah, I want to point out too that previous diagrams did not include our Cozy CSI adapter, and so that's included here. It's just for simplicity in the Cozy system namespace, but I mean that's subject to change. The green line just indicates that it will be communicating data read from the bucket access and bucket through the kubelet and injected into the pod via a CSI ephemeral volume.
Just this is just pure curiosity.
Mm.
How does that work? Does
So,
so I mean, is it write some detail into? I mean, I don't know what the scope of a volume is. Can you centrally write to an ephemeral volume and have that data available on the node, or I'm just a little confused about.
The volume.
Yeah,
Sorry.
thanks.
The volume is not meant to pass along any data really. The volume just exists to prevent pods from being scheduled when a bucket is requested by a pod and before the bucket is provisioned. So all it does is.
I thought the point of the CSI driver was to write the credentials, though.
Yeah, so that was my understanding too, actually.
The original reason we brought it in was to prevent the scheduling. Now, the CSI driver could be leveraged for putting credentials in. However, it might just be easier to create a config or a secret and just mount it.
Right. So that way back in the day, that was the approach, was a secret. And I think we had feedback from Saad that he was effectively uncomfortable with the secret because he felt like it was managing something that is not normally managed in an automated way. That's a user provision thing normally, and having us kind of manage lifecycle of it and everything else. And he felt like communicating information through a dedicated approach, start off with ephemeral volume and then eventually end up having some kind of first class thing, which would have all of the security benefits of a secret, but would have the additional manageability benefits. That's sort of how I interpret it.
Yeah, that's fair. That makes sense.
Sorry, go ahead.
Saad, please.
I'm here. Great. He can speak for himself. Sorry.
Yeah, no, I'm in complete agreement there.
Yeah, I think additionally, users won't be able to modify secrets in their namespace, which is also a nice property.
I'm sorry, do you mean modify secrets that we were to generate or modify the sets of information that we pass in?
In our previous design where we just copied secrets from non-namespace to user namespace, users were able to modify these secrets in their namespace. Right?
Oh, I'm sorry, I misheard.
For whatever reason.
I misunderstood you. I thought you said weren't able to modify secrets, which didn't make sense to me.
So again, back to my question. So the one benefit with secret is the secret data is effectively stored in etcd. And so it is accessible to kubelet sort of inherently. I'm wondering at how the data for an ephemeral volume kind of gets there. I guess my question is, do we have to have an agent running on the node to write that, is my question.
Yes, yeah. So all CSI drivers have a component that runs on every node. And then that component is responsible for setting up the mount. In this case, what will happen is they'll carve out some scratch space from the host machine and temp directory, and they'll then write in the contents of whatever needs to be written in. They'll pull in the contents based on the objects that are referred to. So your bucket access object and your bucket request object, it'll look at those, figure out what needs to be written, create a file, and then surface that file up into the container.
Okay, so the implication is there's going to need to be a daemon set or something then that does this piece. Okay.
Yep.
And Saad, is that a separate component, or is that something that is provided by CSI, like another sidecar? Through?
It should use the standard set of sidecars, but in this case, the logic that's going to go and look at the bucket access objects or the bucket request objects, all of that's going to be custom for this driver.
Right, right. And that, so my understanding so far, I've been trying to, read up on CSI ephemeral volume. So the two methods on the node service interface that we need to implement are, was it node publish volume and unpublished volume?
Yep,
are
that's right.
those the methods that are going to be interacting with the host file system, or is that a
Right.
separate system? Okay.
Yeah, those are the ones that effectively it's mount and unmount. So it's saying, hey, I have a driver, I have a volume that's asking me to do a mount. Please complete this mount operation. And the end result of it is at the specified directory, the volume should be mounted. And so you need to create a temporary directory somewhere and then link that to either mount it or bind mount it or link it to the target directory and make sure the content of what you want is inside that directory. And that should be it.
Got you. Okay.
So this begs the question then, if I've got a daemon set that represents part of my CSI controller, right, because I've split it into the two, how does that daemon set piece get access to this information?
The daemon set will have, all right, so the way that I've written this graph was under the assumption that the COSA CSI driver here, one, it's listed as a pod, that should be a daemon set. I can correct that. My understanding was that that would be the daemon set that was distributed across nodes. It would have a watch on bucket access and bucket objects. And at the, I forget which field it is, but once they indicate that the provisioning has been completed, the CSI adapter will then use the client, the CRD client, to read those objects, and then, oh no, I'm sorry, I've got this backwards. I'm still remembering the CSI portion of this. The pod itself has to have a reference to the bucket access request written as a CSI volume. When it's created, the pod will block. The kubelet will detect that, and that's one of the reasons it blocks. The kubelet will then call the node publish volume method, which is implemented by the CSI adapter. So does this sound right so far, or am I off track here?
Yeah, I think Andrew's question is more along the lines of how is the daemon set that we're going to deploy for the CSI driver going to have access to the bucket objects? And we have to set up the RBAC rules to allow that.
Yeah, so it sounds,
Oh,
yeah, so
at the Kubernetes
that
layer,
was the
okay.
part that I realized as you're describing it, it's a dumb question. I should have just stopped you.
I mean, it's not a dumb question.
No,
It's
no.
an interesting one because, especially because we try to avoid giving too much access to components running on the node. In this case, we're going to have to think through the security implications of deploying a daemon set that has access to all bucket request objects. But since this is not a permanent solution, I don't see that as a blocker at the moment.
And it also isn't open access to cluster scope. It's just those specific ones. So.
Yep.
Yeah,
Right.
so that's the short answer is we're writing this credentialing information into the actual bucket access object, the non-namespaced object. That either in it or in a secret next to it. And then that means this piece running on every node has access to that. We'll read it from the and then write it locally.
Yep.
If
Right.
this is a temporary solution, what is the permanent solution that's envisioned?
I would imagine. Yeah, go ahead.
Oh no, I'm sorry. Go ahead. Yeah, I think you have probably a better.
No, I was going to say kubelet. Same thing that we do for persistent volumes today.
Okay,
Kubelet
so
is
it will
going
move
to,
into kubelet. They just can't. This is an acceleration.
yeah.
That would
If
be
we
slow.
can convince SIG architecture, that is the goal.
Makes sense.
Yep. Has this diagram generated any more confusion or questions that I could answer before we move on?
No, it's just the one
bucket.
thing.
Sorry, go ahead.
the impression this is a central controller rather than a daemon set. So if there's some way to make it look like it's clear there's instances of these on every node, that would be helpful.
Right. Yeah, I can make that a lot more clear. Okay.
Hey, so bucket requests are namespace, right?
Yes. Yeah, they'd be in the application namespace.
Okay, so the information that the CSI driver would need RBAC access across namespaces, though, right? Like
It would
have to.
yeah. It would have
Would,
to, at a minimum, be able to dereference the bucket access object to get access, and then through that, the bucket access will give it credentialing information if it exists. Otherwise, it would be through the service account in the namespace. But the connection information, the way I've envisioned this thus far, would be associated, written into the bucket. So you're right. Like there's some amount of access that the CSI daemon set would have to have in application namespaces.
so instead of doing that, we could think about creating a persistent volume. The CSI driver already has a provision for passing in secrets and custom parameters, and we could put that information in the volume, and the CSI driver would get that information and it tries to mount it.
And that PV would be created as part of the provisioning process then, right?
Right.
Okay. So you'd have a PV that kind of melds bucket access and bucket together. The kubelet would access, or rather the CSI adapter would reference that as it was referenced by. But that how does the kubelet know which PV to get to, right? Because if this is a cluster scoped object, whoever wrote the spec for the pod still has to say, hey, I want that bucket injected into this pod. Should that PV, right? So like that means that he has to say, okay, either look in the bucket access request or the bucket request. But to communicate that to the CSI adapter, it still has to have some sort of visibility into that namespace. So I don't know if that closes the loop for us.
John, I don't know the answer, but maybe this helps. Does Kubelet have access like to the PV and PVC in the API server?
You mean to pass along to the CSI driver?
I mean, for read, in order to
Yes. Kubelet needs that access so that it can tell the CSI driver what to mount.
Right. So isn't that really the same model here? Right. Eventually, we want that to be the. I'm not sure if we can do that now, but
Yeah, it's actually something exactly like that. That's a good analogy, I would think. Yeah. And we won't have to deal with the new RBAC issues. I mean, it's not really an issue, and I don't even know if that should be necessarily considered an issue.
Clear, what you're arguing is that the final approach, where we're going to go with Kubelet doing this, has some benefits. So I think we all agree with that. I guess my question is, do you think there is a near-term way that avoids RBAC that doesn't involve having to modify Kubelet to understand this?
I see.
I'm saying the controller could be the one with the permissions that ends up creating a persistent volume that's supposed to be provisioned by our custom CSI driver. And in that persistent volume, you can pass in secrets and opaque parameters, which then end up in the CSI driver.
So how do you pass those secrets and parameters? I know how to do this in a storage class, but how do you do it out of band like that on a per volume basis?
Doesn't
So
the sidecars do that?
Sorry?
Sorry, I may be jumping the gun but I thought the sidecars do that, like the provisioner. right?
No, I think he means like how is the information written into the volume?
Well, what I'm saying is that the sidecar today reads the secret information, puts it in the gRPC object for the CSI, and then that is passed to the CSI driver, and then the driver can do whatever it wants with it.
Sure, I understand
Right.
that. The question is,
Okay.
how does the sidecar get it? Right.
Yeah.
My understanding is the only path for providing it to the sidecar is to basically put it in the storage class, because those things are passed in. But there's nothing on a PVC that you can pass in a secret that then
Yeah.
gets right. That's what I'm.
Okay, I get it. There's a way to pass in the name of the secret. You can do that, but the secret at least must come from either one namespace or from the namespace of the PVC.
I see.
So can I talk a little bit about this? I think the idea that you have is kind of right. You're trying to minimize the amount of access that you're going to have to give these new daemon sets for the CSI driver. And you're right. You could, replace this with just a standard CSI driver that uses PVCs and PVs. But then we kind of get back to the original problem that we had, which was, how do you tell the pod which PVC to use? And you don't want to have the user go and create these magical objects, because that's no different than creating a magical config map or creating a magical secret object to point your pod to. Instead, by using this approach of having a special CSI ephemeral driver, the user just says, I am using a bucket resource via the CSI driver, and then any custom parameters they want, they can specify as part of the pod inline. And then the rest of it is kind of handled automatically, so it leads to a better user experience. Does that make sense?
Yeah. There is a mechanism to have constraints on the CSI volume binding. So if a pod is requesting a volume through a volume claim, we can make sure it always just matches a particular volume for that bucket.
Right, but that still requires the user to request a specific volume PVC, right? How do you do that?
No, I'm saying they just have a volume claim. They don't request a volume. They just say,
What does that
volume
claim have in it? Who creates that claim?
The user would have to do it, but wouldn't the user have to do it even in case of the ephemeral volume?
No. So the way ephemeral volumes work is they don't use PVC. They allow the user to provide inline storage provider specific parameters that are then used at pod runtime to provision a new volume. And then that volume is deprovisioned after the pod is completed.
Right, I understand that. My question is more along the lines of, are you saying the user has to provision the volume in the sense that they'd have to manually go and create a PV for the PVC?
No. I'm saying the user has to manually create a PVC object, right?
Mm.
What is that PVC object going to look like? What are they going to put in it? How is that going to get interpreted correctly?
And how does it not just generate dynamic provisioning of a volume?
Right.
Right. No, I'm saying it
So
should generate a dynamic provisioning.
Right.
And the controller
but then what are the parameters that you're going to set to allow it to generate the right type of volume that is specific to a specific bucket? The PVC object doesn't let you customize anything per storage provider.
I see. Yeah, that's where I misunderstood. I thought the PVC object could take in a custom set of parameters.
Gotcha. Yeah, no, that's specifically not the case.
That's my point. That's indirected through the storage class, which doesn't give you fine enough granularity.
Mm-hmm.
Right. I thought it might help also to illustrate Saad's point that we're not using PVCs and PVs here. So if y'all can read this spec that's on my screen now, I hope, can y'all see that, or am I just sharing Chrome right now?
Oh, yeah, we see it.
Okay, cool. So yeah,
I
so
see
the,
it's a little small. It'd be great
a
if you
little,
could.
still, oh boy, okay.
I think we're just mesmerized by the YAML.
Yeah, I know. Show a bunch of
All
cute
right,
guys. Yeah,
that's
we'll
what.
just sit there. Okay, so the, to kind of illustrate what Todd is talking to. So instead of specifying PVs and PVCs, you still define a volumes stanza. Under it, you name your volume, and as a volume type rather than PVC, you specify CSI. You name your driver, and then it has a node publish secret reference. I'm not certain how that's used quite yet. And then it has volume attributes, which is a string map. It was my imagining that we could then specify our request objects under here, and that's how the user would point their CSI volume to the request, so they could indirectly, get the bucket access. Then you define your mount points within the pod, and if you're using AWS, for example, you'd specify a common destination for those. For the connection information, there's not really any, I don't think any cloud provider has a default path for writing this informational file, or if it's even a common practice for them to read from files. So that's something that we would probably be asking users to have a little script to inject into their environment or inject into the workload as arguments somehow. But that would be the flow. So the kubelet would see this defined here, make a call out to our CSI adapter. CSI adapter would go out, perform the operation specified per here. This gets passed on to the CSI driver, get the credentials, return it. I think at that point, this is where my understanding gets fuzzy. My thought was that it returns this information to the kubelet, so the connection or the marshaled connection or credential data as some sort of file format, which the kubelet would then write.
That's all mostly correct. I think the only difference I would add is you don't need the node publish secret or FS type there. You just need the driver and volume attributes. Okay. And like you said, volume attributes can be custom. You can add whatever you want underneath there. And so once the pod is starting, the kubelet is going to say, oh, let me see if there's a local driver, a CSI driver called CSI CASI adapter. It'll make sure that that's registered. Then it'll make a node publish request to that driver and pass these parameters to it. And then that driver is responsible for spitting out a directory that kubelet can use to mount. So that's all kubelet cares about. It doesn't care about the details of any of this. It just says, give me a directory that I'm going to mount. And so the driver is now responsible for creating.
Is that, I mean, where does it, is that a host path directory? Does it write on the local?
It's a directory on the root file system. Since kubelet operates on the root file system, it just wants a directory on the root file system, and then it takes care of pushing that up into the container.
How do you properly reserve space? Is that something where your CSI driver has to provision a volume, or?
Yeah, your CSI driver has to figure out where to get disk space. So maybe use a temp directory and generate a name and make sure there's no collision. That's up to the CSI driver.
On node publish, the caller gives you the target.
Yeah. Sorry,
you make a directory under this tree.
Yeah, there's two directories. There's a source directory and there's the target directory. The target directory is generated by kubelet, which ensures, like Luis said, there's no collisions there. So kubelet gives you that target directory that you should mount something at. The source directory is up to your driver to figure out. Does that make sense, Andrew?
Yeah, I'm still missing a little bit, but we can take it offline. It's like I said, it's reserving disk space and everything else, and what's at the container level and what's at the host level. These are all sort of the things I'm not quite.
For the purposes of the CSI driver, assume everything is at the host level. And the final target directory is a host level root file system directory. And once kubelet has that, the CSI driver is out of the picture. It's up to kubelet to figure out how to surface it up into the actual container.
Exactly. Should we take special care to garbage collect to kind of clean up after
Yeah.
pod is
That's
gone?
part of the spec too. Yeah.
Yeah,
Uh-huh.
so it's part of the spec. You'll get a node unpublished request for that volume to do the cleanup.
And it's a guaranteed call, right? So it's not possible to miss it, right? So it's,
Correct.
okay, nice.
One question here. So what will be the volume handle in the node publish callback in this particular example?
That's a good question.
There's no volume handle specified. For these ephemeral volumes, they're automatically generated by kubelet. And so you'll get a special unique volume handle per pod.
I see. Sure. Thanks.
Just one thought here. It's a little bit tangential to what we're talking about, but it came up in the environment variable reference. One of the things that we ran into when we were thinking about this, and I think it's worthwhile considering, is what if an application needs access to more than one bucket? And one of the problems there is mapping environment variables or something like that isn't as straightforward when that's the case. So
Yeah.
it is having a representation in the file system can solve that, but
Yep.
assuming
Yeah,
we're
so in
gonna-
this case, you would have potentially two volumes here. One you could call creds1, another one creds2, and they could point to two different volume attributes, different bucket access requests. And you would just need to make sure that the CSI COSI adapter was able to, handle them uniquely and generate unique files for them.
Okay, I would like to move along now. We're about halfway through the meeting, and there's a few other things I'd like to cover. Please feel free. So that again, the diagram is in the KEP. Please feel free to take a look at, leave notes. So the next thing I wanted to take a look at was references. Oh, sorry, I think I mixed my slides up. That's okay. Back references in terms of managing the attached bucket requests to buckets, so that a bucket object has a list of many bucket requests that the central controller would manage as a way to enable delete operations. So there's two cases for this that would differ slightly, and there's a lot of questions around them. But if we can start talking about them, then I think we'll have something to think about next time. So the first case, greenfield, the first question is, what happens when the originator of a greenfield bucket deletes their bucket? And the second follow-up question is, well, should other namespaces be allowed to attach to someone's greenfield bucket? And then the third question, which is now implication of the second, how does the originator define which namespaces can connect to his bucket? So the first one, again, if I delete my greenfield bucket, should it be removed from the cluster, or should consideration be given for other namespaces that may be accessing it? Ignoring for a second that other namespaces may or may not be accessing it. Excuse me.
Are you asking, or are you going to take a position?
No, sorry, no, I don't. Yeah, I'm asking. So I don't know what the right answer is either way. My initial reaction is to say, well, if I'm the owner of a bucket on a platform and I delete my bucket, that's my right. I own the data. If other people are accessing it, tough cookies. I don't know if that's something we want to represent in Kubernetes or not. And so that's my question. Is that a behavior that we want to enable at the Kubernetes layer?
So here is a way that I've been thinking about it. Let's see if it has any resonance with folks. I feel like that you've got three different considerations. You've got greenfield, you've got brownfield, and you have the desire to leverage a greenfield generated bucket into a brownfield scenario. right? So I'm intentionally separating those three. So in a pure greenfield, I hope people would think that it would be a normal thing to expect to be able to create a bucket and then delete a bucket and expect that you could also delete the underlying bucket, right? So bucket request comes, goes, the underlying bucket goes. So, and you would expect, just from convention's sake, that that could be controlled by a parameter on the bucket defaulted from a bucket class, right? Just like storage class does for PV cleanup. I think it would be also reasonable to expect that a brownfield situation should never, on the case of a brownfield request, delete the underlying bucket. So greenfield by default could, has the option to not, brownfield never does. So then there is this interesting problem of what happens if what you have in the diagram here is done, which is I do a greenfield provision and then I point a bunch of brownfields at it. My question is that a realistic point in time scenario? In other words, I could totally see a situation where I have run an application, it's created a bucket, and then at some point in the future, I've said, you know what, I want other applications to be able to talk to that bucket. The question to me, whether that's the same bucket for the greenfield as for the brownfield. In other words, should that be a separately provisioned bucket rather than just reusing the bucket that was provisioned via greenfield? Does that make any sense?
Yeah, Andrew, I think you stated it well, and I'm on the same page thus far. And to kind of give maybe an example, the way I think about it in a real world sense is, say I run a workload, I create a bucket. My workload's job is only to populate this bucket for a machine learning AI test set. It does that, creates the bucket, fills it with petabytes of images or data or whatever, and then it goes away, and the namespace can go away. I'm running other jobs in this cluster in different namespaces, all of which would like to read from the single, data point. So should we allow that? It seems like we should, but how we enable it is.
I think what I had imagined in my head was your bucket object has a retention policy, and if that retention policy is delete, before the deletion occurs, the controller verifies that there's no bucket requests pointing to it. And it doesn't care whether the bucket was originally provisioned as greenfield or it was a brownfield object created by the user. All it says is, as soon as all the pointers incoming to this bucket object are no longer or have all been deleted, then I will go ahead and delete the underlying bucket as well. But as long as at least one object exists pointing to it, then I will not delete.
So the question is, how do I, as the bucket creator then, and maybe this was the other thing you were saying, keep other people, how do I assert ownership?
Right. Yeah, right? So there's that permitted namespaces. So if I really care about that, I will only make sure that my namespace is in there and nobody else can go and grab it.
So to that point, so that this is where things get complicated. So identifying a user is somewhat trivial. The bucket object is created by the COSI controller. So this would be automatically populated with my namespace because I by default should have access to it.
Well, you have two options for default. You could do that where you put it as just the namespace of the originating bucket, or you could leave it empty, which could imply that it could be anyone, and you need to decide.
Oh, I was actually going to suggest a private mode, which is only the originator gets access to it. And so basically nobody can attach to it beyond what it was originally provisioned.
Yeah, I think that's what John's proposing as well. So either of those would be reasonable.
Yeah, so a binary choice. Gotcha. So like a binary choice, then me or everybody.
I mean, as a default, right?
Okay.
We want the actual field to be customizable to support multiple namespaces, but what is the default that would be set when we do dynamic provisioning?
what I like about this approach is if I come in with a green field, by default, nobody else can attach to it.
That
Then
seems
if I
reasonable.
decide to go into the bucket and open it up, then I'm kind of making the policy decision at that point that the greenfield guy doesn't own it
Mm-hmm.
because I've opened it up. I mean, that's kind of how I look at it.
Does it also imply that bucket itself won't have any information about whether it's green or brown field? So it's going to be like just a bucket?
Effectively, yes.
Because that
The
would
only
be really
difference,
nice, I think.
yeah, the only difference is going to be when the bucket is created, what is the default that's set?
That would be great. Yeah, I think if we come with that model where it's like after we create it's all kind of unified and life cycle is unified between these two use cases, that would be really great to have that.
Yeah, I completely agree.
Okay, so in terms of giving users the power to do this, obviously it means we have to have fields now in the bucket request. So I would propose, at least as a starting point, adding a permitted namespaces to the bucket request, which is the slice that could be represented by some predefined string value. So an empty string meaning only me, it's private. Otherwise, a star being the second sort of default indicator of release it to everybody, or a third option that I guess would imply give it to me, but also give it to namespace X, Y, and Z.
So,
excuse me.
I'm a little bit uncomfortable with this, and the reason is because I feel like you're getting now into a realm of interacting with other resources for which you, the administrator, or you, the person who's authoring the bucket request, may not have in your administrative domain. And so I don't have any problem at all with the non-namespace resource being able to manage this, but it feels a little bit weird for the request side to manage it. I guess I'm saying I would expect that if this is a green field, you just get closed by default. And if it's brown field, you're getting whatever's already on the bucket. And then if somebody wants to open it to other things, then they would actually go edit the bucket. Now I realize that probably closes off one possibility of hey, I happen to have apps in two different namespaces that I both have access to. Why can't I allow this bucket to be shared between them? That's the one weakness of the model I'm suggesting. But the flip side is just, this feels like it's really a non-portable kind of thing that you're putting into the portable side request object.
Right. So on that note, and that's where I've been stumped in trying to get this implemented. My mind has been mostly towards this as an administrator level action, and it should be defined on the administrator level object. If we were to allow users to do this, it would have to be on the user side API, of course. So the alternative then is that we ask cluster users to make a sort of out of band request to an administrator to please open my bucket up to the rest of the cluster to namespaces, foo and bar or whatever.
But that's
Andrew, can you please
anyway.
provide more information why you are concerned about that? I'm trying to understand for Greenfield, I'm actually asking to create a bucket. So why that would be bad to actually say who I wanted to share with?
Because when creating a bucket, if you are saying who you want to share with, you're now making statements about the state of the cluster and things that are no longer specific to your workload, right? I mean, there's, if there was some sort of meta workload description and you could say anybody from this meta workload, that would be one thing. But this gets to be a very specific kind of permissioning at the request level, which, I mean, I just don't think there is really much of examples of this. I forget the word I'm looking for. But most of this kind of permissioning stuff is generally done by non-namespace resources, either IAM or other kinds of policy statements. You just don't see those kind of policy statements in the workload objects.
Yeah, I think you're right. Yeah, I probably agree with that. Usually when users operate on something, it's usually namespace scope, right? And here you go beyond one namespace, which is actually probably against what Kubernetes usually has. Okay, that makes sense.
So in that scenario, then we're saying essentially that users don't have the the permission, or the shouldn't have the capability of setting the sort of shareability of a bucket instance. Is that right?
So, yeah, I think I was originally, when I saw this, John, I was like, oh yeah, that makes perfect sense, but I can buy Andrew's argument, especially around kind of portability. If you start sticking namespace, kind of allowed namespaces in there, what if you move this object into that namespace and it gets kind of funky? I want to go back to a idea that we had before, which was a bucket class. I assume we still have a bucket class, right?
Yes. Let me. So we have something to look at here.
Could we update the bucket class to have this permitted namespace field? That would be cluster scoped, so it would get around that issue, but it would still allow you to customize in this way.
In that case, what you're saying is that I'm, as a user, go to the admin and say, hey, create a class for me. I'm planning to share this bucket across these two namespaces, and an admin will create a bucket class.
Just to note, you already have to have a class.
Right. Right.
So this is asking for parameters in a class. And let me just point out that exactly what John had started over there, I think could be useful here as an option, is to say public or private, right? That would allow the notion of a bucket class that's actually reusable. A bucket, then specific permitted namespaces could also be something that we have. So it could be all, none, or listed. But that gives you then the flexibility to be able to have a couple of well-known, public-private ones, and give access to people to being able to do that. And then you can also handcraft the specific one, which would be the request to the cluster admin.
Yeah, I still feel like public-private on the bucket request seems to have the same flaw as basically specifying namespaces, because you don't, as a creator of the bucket request, you shouldn't be able to do that.
You wouldn't have it on the bucket request, but you would refer to a public or private bucket class.
Okay, that makes sense. To my point that I meant, like, it almost looks like maybe every user in the cluster will need to go to the admin and ask to create a bucket class just for them, so they can, if they want to share the same bucket across, for example, multiple namespaces of their own.
Yes, I agree. I just don't know how often, So look, we already say the brownfield case already requires.
I'm not saying that that's bad. I just try to kind of to understand the flow. Like, if that's the flow, I'm not against it. It's like, sure, if that's a use case.
I'm saying effectively bucket sharing is brownfield, effectively. And so whatever control mechanisms we want to put on brownfield would apply to the case of greenfield generating a bucket that then is available for brownfield use. That's all. And so to me, it makes perfect sense that those constraints are privilege constraints and not specifiable by the user at the request level.
So it sounds like we're in agreement. The bucket object should have a permitted namespace field that defaults to just the most restrictive. And then the bucket class should have a field that allows you to open that up potentially. And
I think it may default to bucket class, right? So in the bucket class, you can specify what are the permitted namespace, and it can default to that.
Right, but if that's not specified, it just defaults to the most restrictive. Or if it's manually created in the brownfield case and the user doesn't specify it, it just defaults to most restrictive. And then the bucket class, similarly, if you don't specify it, it just defaults to most restrictive.
And just so I'm clear, the bucket class, the permitted namespaces field there, even if that's defined, we still assume that the originator is also allowed. So this is in addition to.
You know, yeah, I was thinking you could rename it, instead of being permitted namespaces on the bucket class side, you could call it additional permitted namespaces. And so if it's,
yep.
Okay, perfect.
Who's presenting here anyway?
It just makes me think that my font's too small is all. Okay, that seems pretty reasonable to me. Is there anyone else before we move on that has any comments or questions about it? Okay, I'll take that as a no, and if you do, feel free to drop a question in the Google group for this work group. And so I had this slide here similarly to kind of represent how this operates in brownfield. Given our discussion that permitted namespaces on the bucket plus the bucket class would be defined by an administrator, this has already kind of worked itself out. So it's effectively the same model as before, just without defaulting to some originator namespace.
So I think you're taking a position here, and I don't agree with it, but I just want to call it out. And that is that you look like you are individually listing every single back reference, right? So there's an array of these, right?
Yes, and these, so let me clarify this. This would be a controller managed pseudo-synchronous list. I was going off what I remember from last week's discussion, and that was that there may be a need for buckets, both greenfield and brownfield, to manage a list of similarly to like a claim ref, so that we know from the bucket API how many requests are attached to this bucket currently.
But correct me if I'm wrong, is claim ref part of status today?
I don't think it's part of status. I believe it's part of spec.
Right.
And sorry, go ahead.
Yeah, the reason I was mentioning that is because, there's the whole unreliability of status question, right? And so if you put that in status and then you lose it, the question is, how would you reclaim that?
I suspect in Snapshots API, it's in status, by the way. It's not in the spec.
Okay. All right. So if that's not well, I assume that in Snapshots API, then there is an assumption there's a way to reclaim it. And I guess there is maybe here too. You could just go out and look for all the bucket requests that refer to the bucket.
Right,
Yeah.
right. And my take on claimref being in the spec and PVCs was that it was part of the heritage of PVCs where static binds were one of the initial things, and so that had to be defined in the spec.
All right, fair enough.
What I may be a little bit just tiny uncomfortable with is that this list may grow, and we have some limitation on the size of the resource we can have in Kubernetes. So that might be somewhat we need to maybe beforehand set the maximum number of requests referring to the bucket is this, and just.
So what happens when we reach that cap? Because a bucket endpoint itself allows.
I think update is going to fail, I guess. I'm not sure, but it's just my wild guess.
No, and that makes sense. But in terms of behavior in the cluster, if a bucket request tries to access the bucket, the list is full. Maybe it's hit some upper limit that we've hard coded. Do we prevent that from accessing the bucket, or do we just go ahead and say, well, we're just not going to track that one? Because that wouldn't be reflective of real world, access, because these are just network endpoints. You could have thousands, tens of thousands.
Sure. Yeah, I thought maybe we would like to say this is the hard limit, so you cannot go beyond, or instead of just relying on the size of the bucket, which may be different. So sometimes you are able to connect many bucket requests, and sometimes that many bucket requests, depending on the size of name and namespace and other parameters. So
I have a thought that goes completely against what I said last week. So if we manage well that greenfield, brownfield transition model that we talked about, then there becomes an interesting question of, do I really need to know who references me?
Mm-hmm.
Right? Because the only thing that I care about then is the edge. Because I'm not going to clean up the requests, where I'm just going to refuse to delete the bucket while I have outstanding requests, right?
Mm-hmm.
So I'm back to thinking maybe we could just do this with a reference count.
Right, and then you don't have a limit on status and the size of status, and if there's any reliability issues with etcd. I'm not sure what that point was, Andrew, but a counter is going to be a lot safer than an array for thinking about scale.
Yeah, you just got to make sure that it's an atomic counter and all those kind of considerations. But
however, from a usability point of view, I look at some resource and it says there's 20 references to this bucket. The next obvious thing is, well, who are they? And so then a tool could figure that out, though. You know, it doesn't have to be in the status as an array.
Can we just suggest any type of decision that might be based on this count, other than the deletion of the bucket itself? Or is that, if that's the only case, it can also just list the when we come to reclaim something like that, like delete a bucket, we can check for references. But the question is, do we suggest some logic around this?
let me see if I can see what you're saying. You're saying that if this is only cared about at the time that we go to delete, you're saying maybe we don't even have to keep a count. We just dynamically query for references, and
well, maybe but let's see if there's other use cases. I'm curious. I don't know.
Well, that's interesting, and it could be a Boolean, not a counter, too.
Sure, and I guess the other use case, the only other use case I can think of right now is exactly the use case that that Jeff just mentioned. The whole I want to know who has references to this. So it's an admin informational thing rather than a code trigger thing.
Right.
But do you think an admin wouldn't like similarly query the bucket requests to find that? I mean,
no, I don't necessarily disagree with that.
Yeah, I don't like personal access count because I'm not sure if it's even possible in Kubernetes, because it's all about idempotency, and here with the counter you cannot go idempotent, right? So it's like I'm not sure if it's even possible to implement in Kubernetes.
Yeah, just by the nature of the asynchronous requests, and I also worry about like race conditions at like the the single count. So if someone deletes the last bucket accessing this, but another one comes up and that bucket vanishes in between.
Hello?
Good use case or user situation.
Yeah, so are to either list all of them, which have the obvious issues, or don't put any back references at all and dynamically query the forward references at time of delete, which has race condition issues, but is at least point in time reasonable.
I'm not sure if it has. I mean, you can mark the bucket before you do that.
I think it's going to be racy. There is no such a thing as transaction, right, in Kubernetes. So like between multiple resources. So it's.
I think we're going to need to think through this design.
Okay.
It's going to have a lot of race conditions. It's going to be a pain in the butt to code. Maybe let's set aside time to actually just walk through the design of exactly what this controller is going to look like and whether you're going to have a back reference or not and all of that.
Yeah. And unfortunately, we've hit the top of the hour here, and we're only about halfway through the slide deck. So feel free to, if you want to take a look at that, drop comments. I can answer questions, on the side. but I don't want to run over because I know people's time is valuable. So is there anything anyone wanted to say regarding what we've gone over today that they'd like to get in, didn't get a chance to?
Good work.
All right, thank you.
Yeah, thank
Are
you.
we gonna
Take
have
care.
are we gonna have another of these next week to continue?
Yes, yeah, we can pick
Okay.
up on the slide deck next week where we
Yeah, I just
left
point
off.
out that next week at this time is, at least for us, a company holiday. I assume that might be the case for
Yeah.
others.
Lots of people will be on vacation next week.
Yeah, I'm going to be out all next week myself. Yeah.
Okay.
Can we skip next week and then do the following?
I think that's a good idea. Yeah, let's go ahead and pull it off the
I
calendar.
can, yeah, I can do that.
Okay, great.
Yeah, I just wanted to say that today was, I think, a great discussion, and I really like the idea of unifying green and brown fields. It sounds so much easier now. So I think it was a great meeting today.
Cool. Yeah, thank you guys for coming, and thank everyone for their input. We will see y'all in a couple of weeks.
Thank
Okay.
you.
All right, take care.
Thank you.